Hey everyone, this is the third part of the unit circle recap, and what I wanted to show you today, basically I'm going to introduce a game that I want you to play, and I want to help you get ready for that. So what I want to show you today is just how to quickly find where a radian measure is located on the unit circle. And what I want you to see on this unit circle is when we went around by 30 degrees, we were able to get every single branch of the unit circle except for those middle branches. And when I say middle branches, I'm talking about these. So let me think how I want to say this. Those middle branches, one thing, well, you look to see if you can see something that they all have in common, that middle branch. And I'm not talking about they all have a pi in them, but what else? So I would say that they are the only branches that have a denominator of 4 is one thing to notice. And then you can kind of see this pattern. This is 1 pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, 1, 3, 5, and 7. All of the other branches, they don't have the same denominator, but we're going to look at that. So I would say if you see a denominator of 4, then you know it's going to be one of those middle branches. So here's what I would recommend. What you're going to be given is something like this angle, and you're going to be asked, where is that on the unit circle? So it does not have a denominator of 4, so you're going to know that it's one of those moving around by 30-degree angle measures. And the way that I like to say this is the two ways we got around the unit circle is moving around by 6s or moving around by 4s. And the place we got that 6 and that 4 is when we looked from 0 to pi. And I've asked this question a couple times. I said, how many slices of pizza do you see from 0 to pi? And here you can see 6. So going around the unit circle by 6s, we wrote in 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, and on and on and on. So we know that going around by 6s is going to give us and get us to that radian measure of pi over 3. So if I start doing that, I know the first one is 1 pi over 6. The second one is 2 pi over 6. And that's actually my answer right there, because that reduces to pi over 3. So ultimately what you are trying to get to is, where is pi over 3 on the unit circle? And it's right here. Okay, the next one we're going to look at is, let's do 4 pi over 3. So 4 pi over 3, are we gonna get to that radian measure by going around by 4s or going around by 6s? And that is, again, going to be going around by 6s, right? It's gonna be one of these angles where we were going around by 30 degrees, right? Maybe an easier way to say it is it's not one of the middle branches because it doesn't have a denominator of 4. But going around the unit circle by 6s is going to give us all those angles that reduce to either a 3 on the bottom, a 2 on the bottom, or it just leaves a 6 on the bottom. So if we go around by 6s, we have 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6. And there it is right there, because that reduces to 4 pi over 3. I also think the fact that 4 over 3 is greater than 1 means it's going to be after pi, because 1 pi, all the numbers less than 1 are this way, and then greater than 1 is this way. So that's a little clue as well. So again, what you're trying to get to is where is this radian measure on the unit circle, and it is the one that is left highlighted right now in yellow. While you're playing this game that I'm gonna give to you, I would recommend just saying these in your head. So not actually writing them down, but in your head, you're saying 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, and counting around that way and trying to do it in your head as opposed to writing down every single one. All right, the next one we're going to do, let's do something a little bit different. Let's do 11 pi over 6. So 11 pi over 6, again, is that one of the middle branches, or is it going around by 30 degrees? And it is not one of the middle branches because the denominator is 6, not 4. And so you know that that is going around, I'm going to just use the phrasing that I'm used to using, and it's going around by 6s. Because of that denominator of 6. So let me try it now without writing anything down. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6. There it is. So it was that last angle before we hit that full revolution there. So that is where 11 pi over 6 would be located. All right, the next one let's look at is 7 pi over 4. Okay, so 7 pi over 4 we know is going to be a middle branch, and maybe you know where this is already just because of some of the patterns that we looked at, but I would call 7 pi over 4 one of the angles that we get to when we're going around by 4s. I know that's not a really mathematical sounding phrase, but you remember what I mean by that, that if you go from 0 to pi, there's 4 pizza slices there. So you go around the circle by 4s, and I will write this one down because it's a little bit different. We haven't looked at one of these 45-degree angles yet. So we see 4 pizza slices from 0 to pi, so we're going around the circle by 4s. This is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. So there it is in quadrant 4 there. That's the angle we're looking for. So 7 pi over 4 is located there. All right, I'm going to show you 2 more. The next one we'll look at is 7 pi over 6. So that is, let me ask you, is that going to be a middle branch or not? It is not a middle branch because we have a denominator of 6. We also know going around the circle by 6s gives us that denominator of 6. And so we know we're going to be looking at these branches, not the middle branches right now. And let's try it again where we're not writing down the values, we're just counting out loud. So going around by 6s, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, and 7 pi over 6. There it is. So it's that first branch in quadrant 3. And finally, the very last one, let's look at 3 pi over 4. For 3 pi over 4, you would know that that is one of the middle branches because you have a denominator of 4. And so I have this idea of going around the circle by 4s, right? From 0 to pi, we have 4 slices of pizza there, so we're going to count by 4ths, I guess. So the first one is going to be 1 pi over 4, and we have 2 pi over 4, and 3 pi over 4. So that's what we're looking for right there. And that is where the angle is located. 2 things I want to end with. The first one is if you kind of understand this, or not understand, but if you saw this pattern of 1 pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4, those odd numerators, maybe you're just using that to find where those middle branches are as opposed to counting through each time. And that's fine. I think that's great, actually. And then the last thing I did not mention was what's called the quadrantal angles. So on the actual axes, so that would be this one, this one, this one, and this one. Honestly, those come up so much that I find students just kind of have those memorized. Like this is 0 and pi, and then this is halfway to pi, and this is 1.5. This is also 2 pi. So like 0, half a pi, 1 pi, 1.5 pi, 2 pi. If you don't like that, I think you can also do like when you see, let's just take an example of 3 pi over 2. When you see that example of 3 pi over 2, you would know that that is not a middle branch because it does not have a denominator of 4. And I just wrote it by accident. So like 3 pi over 2, you would know that you're getting that by going around the circle by 6s because it doesn't have a denominator of 4. So it's not going to be a middle branch. So if you don't have those memorized, I think you will soon, but you can also take the same approach. I know I said I was done. I keep talking. You can take that same approach of going around the circle by 6s. It's still going to work. So I'm going to just show you that, and then I promise I will stop. So you have 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, and 9 pi over 6. Hopefully you would recognize that that reduces to 3 pi over 2. So that approach still works for those what's called quadrantal angles. So I will leave you there. Hopefully that is going to help you go into this game very soon. That's probably one of the most challenging parts of it.